All right, so here is our next group of questions, or next batch of questions. I'm going to go through questions 38 through 42. This next question reads, which of the following is not a strong electrolyte? HCl is a strong acid. Sodium hydroxide is a strong base. Calcium hydroxide is a strong base. C12H22O11 is a molecular compound. A through C are all strong bases and strong acids, therefore they are strong electrolytes. D as a molecular compound is not a strong electrolyte. So I'm going to say D is the correct answer because it is not a strong electrolyte. So question number 38, D. Okay, select the coefficients to balance the chemical reaction shown below. All right, so basically this is asking us, it's giving some options. And there's a couple of different ways that you could approach this question. One way is you could just pick answer option A and say, okay, well, what happens if I have a 2 here? What happens if I have a 3 here? What happens if I have a 1 here? What happens if I have a 6 here? And go through and count it all out and say, okay, well, if I selected that option, how many AS do I have on the reactants and the product side? So that's one approach that you could take. And, that's actually the approach that I'm going to go ahead and start with. If I selected A as my best answer option, that's going to give me 2 AS on the reactant side and 2 AS on the product side. Okay. It's going to give me 6 hydroxides. So that would give me 6 oxygens and 6 hydrogens. Then on my product side, I've got, well, that's a 3, so that means 12 oxygens. And then here's a 6 in front of H2O, so that's 6 oxygens. So my oxygens are actually balanced there. That would give me 12 oxygens. My hydrogens, I've got 3 accounted for. Or sorry, I've got a grand total of 6 of them accounted for on the reactant side. And then I've got, let's see, that's 6 hydrogens. Okay, I've got 12 hydrogens on my product side. Then I've got a 3 with H2. That would be a total of 6 of those. So I've got 12 hydrogens on each side. Then this SO4, well, I've got 3 SO4 there, and then I've got 3 SO4 here. So that's a nice way that you can, approach this sort of problem. Just select one of them and go back and forth and add them all up. Alternatively, you could look at it and say, okay, well, if I have an AS here and I've got 2 AS on my products, I got to have a 2 here. Okay, so C and D would be eliminated as good answer options. So I'm going to cross those out, and I'm going to make sure that I'm recording this, and I am. Then let's see, I've got a 2 or 3 for my next coefficient. Well, SO4, that's a polyatomic ion, that's sulfate. I've got 1 sulfate on the reactant side, and then I've got 3 on the product side. So it looks like I've got to have a 3 right here. Okay, so that really kind of eliminates answer option B. So I'm left with A. So there's a couple of different problem-solving approaches to this problem. But at the end of the day, the correct answer for question number 39 is A. All right. Next up is if 22.5 milliliters of a 0.650 molar solution of sodium hydroxide were required to neutralize 15 milliliters of HCl, what is the concentration of the HCl solution? So this is a titration problem, but in its heart, it is a balanced chemical reaction. It's a stoichiometry problem. Now, the way that you address a stoichiometry problem like this is, boom, boom. Okay, there we go. And that's I've got a volume, 22.5 milliliters, which is the same as 0.0225 liters. And I've got a concentration of a sodium hydroxide solution is 0.650 moles in 1 liter, or molar, or molar. My reaction is NaOH plus HCl yields NaCl plus H2O. So 1 mole of this reacts with 1 mole of this to produce 1 mole of this and 1 mole of this. Now, do I have that many moles? No, I don't. I have 0.225 liters and 0.650 molar. So I'm going to take that 0.0225, multiply it by 0.650, and I'm going to learn that I've got 0.014625 moles of NaOH. Okay. Now this question says I'm completely neutralizing this base and this acid. So that means the number of moles of hydroxide that I added is equal to the number of moles of acid that were present. So that means there were 0.014625 moles of HCl. Now the question that's being asked is, what is the concentration of this solution? I'm going to switch back over to my exam. So to answer this question, I've got to take the number of moles, which is 0.014625, and I've got to divide it by my volume of HCl, which my volume of HCl is 0.015, because 15 milliliters converted to liters is 0.015. And for that, I end up with 0.975 molar is the concentration of my solution. So answer option A is the correct answer for question number 40. Okay, next up is what volume of 0.5 molar HNO3 solution is required to neutralize 12.5 grams of sodium hydroxide? This question is similar to the previous question. The difference is that we've got a balanced chemical reaction, which is we've got a chemical reaction, which is HNO3 plus NaOH. This is an acid and a base that come together to make H2O and a salt, NaNO3. Now, with that understanding, that's a 1-to-1 ratio of HNO3 to NaOH. So what I'm going to do is I'm going to say that, there we go. What I have is 12.5 grams of NaOH, and I've got a solution with a 0.5 molar concentration of HNO3. I'm adding this acid to this mass of NaOH. So what I have is 12.5 grams of NaOH. And what I need to do is I need to figure out how many moles of NaOH that I have. So 12.5 divided by 22.9 plus OH is 17. So this is 39.9 grams of NaOH is 1 mole NaOH. So that would be 12.5 divided by 39.9 gives me 0.313 moles of NaOH. Okay, so the question is, what volume of this 0.5 molar solution, 0.5 moles per liter, times what equals 0.313? So to answer this question, we take 0.313 divided by 0.5, and we get 0.626, because 0.626 times 0.5, oopsies, is going to be the 0.313. So this is 0.626 liters, which is the same as 626 milliliters. Now, this was a question that I need to jump back. Okay, we're good there. When you look at the answer options, well, 626 milliliters is not an answer option on there. And that is a mistake. So question number 41, I'm going to give everyone credit for that because I did not put the right answer as an answer option. And I apologize for that. So question number 41, everyone's going to get credit for that. Okay, so draw credit. All right, but that's how you'd approach this sort of question. Okay, question number 42 reads, how many moles of carbon dioxide can be generated if 15 moles of O2 react with 4 moles of C2 or C6H5COO6? Okay, we've got a balanced chemical reaction here. 2 moles of C6H5COOH react perfectly with 15 moles of O2 to produce 14 moles of CO2 and 6 moles of H2O. Now, we are told, so that's them reacting in harmony. 15 moles of O2 react with 4 moles of C6H5COOH. This question is a limiting reactant problem. We've got 15 moles of O2, which is 15 moles here. 4 moles of this, that's 2 times what this is. So we have 2 times this, what we need. That means that this right here is our limiting reactant. And this is in excess. Well, since that's our limiting reactant, and this is an excess, the question is, how many moles of CO2 can be generated? Well, it's not going to change. It's 14. So our correct answer here is A, 14. And that would be number 42. A. All right, well, that's going to be my stopping point for this video. I'll see you in the next video.